This is the second video on simplifying radicals. This time, however, we're going to throw in some variables and figure out how that works. I'll do kind of a detailed explanation on this first one and then kind of talk through the shortcut for what we're going to do. We have the square root of the 16x squared y to the 7th. So in math, we are allowed to separate this out, and we can square root each of these individually, like this, and just worry about one of them at a time. So we take the square root of 16. Square root of 16 is 4. Oh, I forgot to mention the thing that guides how we approach these problems with variables. We need to remember the square root of x squared always equals an x. So the square root of x squared equals x to the first power. So here I have a square root of x squared. That equals x. Now the square root of y to the 7th, because we know that the square root of, this time, y squared would equal a y, I want to figure out how many y squareds do I have in y to the 7th power. Well, y to the 7th power is 7 y's multiplied together, so I can rewrite these, just kind of think about it in terms of what if I group two of them together each time. Y squared, right now I have 4, here's 6, and then I need just one more. And basically what we're doing is we're square rooting each of these. Well, the square root of the first y squared is just a y. Square root of this y squared is a y. Square root of that y squared is a y. And then the square root of y right here, you have to have at least two y's. You have to have a y squared to be able to take the square root. So that one will just stay as the square root of y. And then what we do is we say, all right, well, you have y times y times y. That's y to the 3rd power. And that square root of y stays the same. So that's the long way to do this problem, but I just wanted to talk about what was happening. The shortcut way is to look at what you have. You have the square root of y to the 7th, and in your head, can you come up with how many y squareds fit into y to the 7th? And you could say, okay, y squared, y squared, y squared, there's 3 of them. Just like we wrote out, there are 3 of those, which means that will be your exponent. You're going to have y to the 3rd power out front. And that's this y. So we can shortcut and say, I know that there will be 3 y squareds. If you square root each one, you have a y times a y times a y, so y cubed. And then do you have any leftover y's? Well, if you have 3 groups of y squared, that gets you up to 6, and you need 7, so you have 1 left over that stays underneath your radical. So there you go. That is our simplified answer with numbers and radicals. Alright, so I'm going to just do the shortcut version of this going forward. But again, rewind, watch this part right here as much as you need to, just to kind of hear that explanation. Alright, so our next example, we're going to square root everything underneath here. We're going to square root the 50, the x to the 10th, and the y cubed. When we square root 50, we don't know the square root of 50 like we knew the square root of 16 on the last example, so we want to go ahead and reduce that. What perfect square number fits into 50? And if you go through your list, 4, 9, 16, 25, 25 fits in twice. So we can go ahead and take the square root of 25. Square root of 25 is 5. And then that square root of 2, I'm going to go ahead and put it over here because I may have some x's or y's that will join the 5. That 2 stays underneath the square root. Alright, now we have to square root x to the 10th. So again, our shortcut, how many x squareds fit into the x to the 10th? And there are 5 of those that fit in, so it's going to be x to the 5th power. Now we'll move on to square root of y cubed. How many y squareds fit into y cubed? That's just going to be y to the 1st power because only 1 fits in, but you have a y left over. So that's why we're going to have a y left over underneath the square root. And there's that one. Alright, now we have a couple fractions to talk about. Again, I mentioned in the last video, anytime you're square rooting a fraction, always try to do any reducing first. It's just going to be less that you have to square root in the end. Sometimes, and almost always, it makes the problem just easier to do. So if you have the square root of 25 x to the 10th over x to the 5th, just go through one thing at a time. we have this 25. There's nothing for it to reduce with, so it'll stay as 25. Then we have the x to the 10th over x to the 5th. So we can reduce those x's. Anytime you're dividing the same base, subtract your x's, so we have x to the 5th power. And then remember, we are taking the square root of that whole thing. So we're square rooting a 25 and an x to the 5th. We'll just do one at a time. The square root of 25, well, we know the square root of 25, that's 5. So that one's done. And then the square root of x to the 5th. So how many x squareds fit into x to the 5th? And we have 2 of them that fit in, so x squared goes out front. And how many x's are left over? You have an x left over. Again, there's that broken down. Here's our 2x squared, so x to the 2nd power, because we had 2 groups. And then there's that leftover that ended up right there. Alright, last example. Again, try reduce the inside if you can right here. First I'm looking at the numbers 20 over 49. Well, 20 over 49 does not reduce, so I'll just leave it as 20 over 49. Now I'm going to look at the x's. X to the 5th over x to the 7th. If you reduce those and subtract your exponents, you will get x to the negative 2 power. Remember, negative exponents will move, so it's going to end up on the bottom as a positive 2. Another way to look at that, if you have these 5 x's, will cancel away 5 from down here, leaving you with just 2 left over, so your x squared on the bottom. Alright, we are taking the square root of this whole thing. So we'll go through, we'll square root each part. We have the square root of 20, which we don't know, but we can reduce in a minute. Over, when we square root 49, we know the square root of 49, that's just a 7. And then we're going to square root the x squared. Well, remember we know the x squared, the square root of x squared is x. So we have the square root of 20 over 7x. Last thing we want to do is take care of that square root of 20. Can we break that down? Any perfect squares fit into 20, and 4 fits in 5 times. So then we'll square root the 4 and get 2. That square root of 5 stays over 7x.